So it's time already. Today we have two presentations from Ms. Suzuki-san and from Okamoto-san. But I'm thinking Okamoto-san probably is not coming and not presenting because he didn't send his part. So Ms. Suzuki-san is supposed to do anatomy, right? And then Okamoto-san was going to do physiology. But given that he's not coming and he's not doing that part, I just pulled out my slides from last year and we will quickly review that. But that means that maybe next class we will have to make up a little bit for whatever is missing, okay? Then another thing is I already gave you back your quizzes 1, 2, 3, okay? And some of the scores are a little low, maybe. We're supposed to have one more quiz, okay? So one more quiz. We have 4 quizzes in total, and you can exclude one, the lowest score, okay? But even then, maybe it's a little low for some of you. So I'm considering maybe if you want, this is not compulsory, but if you want to raise a little your grade, I'm going to allow you to do a short essay, okay? The topic will be exactly the same as your presentation, okay? So it will be kind of like a review for you for the final exam. There is no length limit because it will be complementary, an additional to raise your score, okay? So, for example, you did lymphatics, right? Yeah. You did respiratory, and you're going to do digestive system. So if you feel that your grade is too low for the quizzes, then you can do kind of like a report, a short summary of your presentation, okay? It's not the handouts written in a page, okay? It's actually writing text, okay? Exactly the same thing as you presented, okay? So, for example, you presented about respiratory system physiology, right? So you will have to make a summary of these. So, because it's going to replace one of your scores from the mini quiz, you have to actually do a much better job, right? Do a better review, write down much more than just phrases or limited things. So you are allowed to do this as a way of compensating for one of the quizzes. Okay, so in that case, you will eliminate the lowest score and you can replace the second lowest score with this new report. Okay, the deadline will be Tuesday 18th because we don't have class on the 17th. Okay, so Tuesday 18th, 9 a.m. will be the deadline. So these will replace the lowest score, the second lowest score for your mini quiz. You may or may not do it. Okay, it's up to you really. If you feel that it's too much work, then forget it. It's all right. It's just for those who feel maybe that just with the final exam, maybe you're not going to pass. Then you can do this summary. Okay, that's the first thing. Then the second one, today we'll have Ms. Suzuki-san present about the anatomy of the digestive system. So you can start anytime. You have roughly 20 minutes or more if you need so. Okay.
Hello.
Hello.
I would like to speak about anatomy of the digestive system. A digestive system consists of digest tract one, two, and accessory organs such as salivary glands means digestion, pancreas means dissolve, and liver and gallbladder means handle. First, I speak about each part of the digestive tract. The first step of digestion is intake food. This is done in the mouth. The mouth consists of these many parts. The most important parts are teeth, molars, incisors, canine, premolar. We must food by teeth and make it easy to digest. This is the most important role of mouth. While we chew, saliva is secreted by salivary glands. Saliva contains amylase and can decompose starch. Saliva also contains mucus, which makes surface of food smooth. This makes food easier for body to digest too. Mouth is very kind for digestive tract. And next is pharynx. Pharynx means pharynx is funnel-shaped organ. The upper side is wide and lower side is narrow. Pharynx is separated for three parts: nasopharynx, oropharynx, and laryngopharynx. The function of pharynx is to move food to esophagus, means shakudo, by swallowing. Pharynx function not just as digestive organ, but also respiratory organ. Then, does food flows down the respiratory tract? No. When food comes from mouth, the epiglottis closes the gate of respiratory tract. Next is esophagus, means shakudo. It receives from food from pharynx. It has two sphincters, Kapiatki, upper and lower. Esophagus moves food into stomach by peristaltic movement with this muscle. Peristaltic movement with the low. Food is pushed out to the stomach by repeating this contraction and relax of the muscle which is located upside and downside of food. Next, stomach. The stomach receives food from esophagus by the lower sphincter. It is located on the upper left side of the abdomen. Stomach's function is storing food and moving food to small intestine. Small intestine means shocho. To move food, stomach will also use peristaltic movement. This is an important muscle for peristaltic movement. Pyloric sphincter. While peristaltic movement, stomach will secrete gastric juices. This contains stomach acid which breaks down food. Stomach wall also secretes mucus to protect itself from powerful stomach acid. Next is small intestine. It accounts for 3/4 length of our digestive tract. It consists of 3 parts: duodenum and jejunum and ileum. Most nutrients, small intestine absorbs nutrients from food. Most nutrients are absorbed in the jejunum, and the nutrients missed by jejunum is absorbed in ileum. To absorb all nutrients, they are ring-shaped bricks and pierced into more on the surface of small intestine, and these make surface area about 600 times wider. First is the large intestine. This is separated for 6 parts: cecum, ascending colon, transverse colon, and descending colon, sigmoid colon, and left side. And cecum is the first part of large intestine. And this ascending colon goes upward towards the liver, and transverse colon travels horizontally across the abdomen. And sigmoid colon is S-shaped and connects transverse colon and rectum. And rectum is the final part of large intestine. And the function of the large intestine is to process undigested particles and to store water and waste, and to absorb certain vitamins. Next, I will speak about other accessory digestive organs: thyroid, pancreas, liver, gallbladder. As I explained at the page of mouth, saliva is very important for digestion. Salivary glands are the organ which secretes saliva. A normal person secretes 1 to 1.5 liters of saliva in one day. This great amount of saliva is supplied from three pairs of glands: carotid gland, submandibular gland, and sublingual gland. Carotid gland is located in between skin and the master muscle. Submandibular gland is situated under the mandible in the skull. Sublingual gland is located inferior to the tongue, anterior to the submandibular glands. Next is pancreas. It is surrounded by stomach and duodenum with juice. It carries pancreatic juice to duodenum through pancreatic duct. The pancreas can produce 2 hormones, glucagon and insulin, and it helps control the blood sugar level. It also can produce many enzymes which can decompose sugars, proteins, fats, nucleic acid. Next, liver. Liver is the biggest organ. It weighs about 3 pounds in an adult. Liver is also the tough organ, so it can be reproduced if it loses 70% of itself. Liver separated into 2 lobes, right and left lobes. It contains a lot of blood. 1/4 of blood is flowed from hepatic artery, and 3/4 of blood is flowed from portal vein. And liver's function is to produce and excrete bile. Metabolism of fat, proteins, and carbohydrates activates enzymes, control the blood sugar level, and detoxify some toxic substances. Next is gallbladder, means tunnel. It is located on the liver and duodenum. It is located on the liver and connects with duodenum and liver. Bile, means sponge, is not produced in gallbladder, but is produced in this liver. Gallbladder receives bile from the liver, then it stores and concentrates and emits it to duodenum through this bile duct. In duodenum, bile helps break down fat. Bile acid can emulsify fat, and it helps repair the digestive enzyme repair the wax. This is all. Thank you.
Okay, thank you. Anybody has comments, questions? Okay, thank you for your presentation. Although much of your presentation, or at least it includes a lot of function or mentions many of the functions, but very little of the anatomy. Like for example, how is the pharynx or the esophagus or the stomach, the walls, how are they composed? Throughout all the tract, the digestive tract, the food is going to be moved, right, from one organ to the other through peristaltism, you mentioned. How is that going to be possible? How are the walls? Did you review anything about the walls? Or on the, can you put your slide of the stomach? This is the stomach, right? So what are the parts of the stomach? The regions. Some of the regions are mentioned there. So basically what you have to do is, you mentioned a lot about what was the function of each of the parts, but mostly that was part of the other student to talk about the function. So you have to talk about location, where are they located? That is very easy, right? Left, upper side, or to this side, or whatever. But then describe the organ. How many layers they have, if it has layers of muscles, some of them are longitudinal, the other layer is circular. In the stomach you will have oblique muscles, because that will give us an idea of how it's going to be moving, okay? When it contracts and it relaxes, right? So if you decide to do your report, you'll have to talk definitely about how is it composed, otherwise it makes no meaning. Just to mention, this is too easy. Who produces the substances? You haven't mentioned one cell. Who produces the gastric acids or the hydrochloric acid to prepare the environment and to digest the food. So it's going to be very important to mention that. Okay. Then for your slide about the liver, can you put the liver? How much is 3 pounds? Probably you took the information from a website. But even if you take from the website, you don't use pounds in Japan. So it makes no sense to write about pounds, the same as it doesn't make sense to say the length of something in feet, because we don't understand feet. So you have to also take care what are you putting in your slide, not only to copy and paste from many websites, okay? What's important is not how many websites you visited or how many references you put, but if you actually took the information from reliable sources. Okay, so I don't care if you put 20 references here, but if you don't mention what you've been asked or the focus of your presentation, then it makes no sense. Because I can see that some of the websites, they are pretty much the same thing. And a website is not going to give you enough information. It's always better to go to textbooks, especially in anatomy, because much of the information is already in the text. So a good textbook, even if it's in Japanese, but the drawback is that you will have to put the English words, so it's going to be tricky. So if you use an English version of a textbook, then it's enough. It's more than enough. The pictures, you can take them, of course, from the internet, and then you put where you took the pictures from. If it's without infringing copyrights and so on, it will be okay. Okay, so anyone comments or questions? Mr. Suzuki, please don't sleep. Wake up. Do you remember anything from her presentation? You want to ask something? No? No. No comments? No questions? Okay, thank you very much. So unfortunately, Mr. Okamoto decided not to come, not to do the presentation, so it's, we're not going to have that part over. Again, please, if I'm letting you do the summary to improve your score for one of the mini quizzes, try to write as much as possible. Okay, not just take from any website. Go to a textbook. Okay, there are good textbooks, anatomy and physiology here in the library. So take those textbooks and write about your part. Okay, not copy paste. Okay, not exactly as it's written on the textbooks. Write it on your own words. Okay, that's what's important. And remember that if you're covering physiology, focus on physiology. If you're covering anatomy, think on anatomy mostly. Okay, what are the layers? What cells produces what, and where are they located? That would be the important part. Okay. So it's very early. I'll try to cover a little bit on physiology. But we will definitely have to make some makeup for next week. So for the next class, actually I wanted to cover reproductive system, but I'm not sure if we can cover as much as I would like to. So probably will be a summary information, summary class of reproductive system, and then we can make up a little bit for digestive if there's anything else to cover. Okay. just to be on the same page, okay, the major functions of the digestive system would be what? Digest and absorb, right? So we eat, we have to process this so that our body can take in, okay? So digestion to break down what we eat, the food, and absorption, passages of nutrients into the blood, so basically, okay? But the gastrointestinal, GI stands for gastrointestinal, has many activities, not only limited to these two. For example, we ingest the food, we put the food in our mouth, and then we have to process, we chew it, right? We have to break it down, otherwise we will choke. And this is active and voluntary, so we chew the food, right? And then we have to move the food from our mouth to the other organs, right? Until the end when it goes out as feces or stools. So the next step will be propulsion, to move the food along the way. And this involves more than one organ. The foods are propelled, they are pushed from one organ to the next one through, and we have very important function, peristalsis, okay? Another important function is segmentation. In a few minutes we will see a little bit more of this. And we also have mechanical breakdown. This is purely mechanical. Physically fragment the food into smaller pieces, right? And these will prepare the food for further degradation by different enzymes. So basically the food, as Ms. Suzuki mentioned, will come through the mouth, will be pushed through the pharynx, esophagus, will reach the stomach, then it will combine with gastric juices, then we'll go to the small intestine, we'll go through large intestine, and then we will release ourselves, right? Throughout this process, it will be mechanically breakdown, will mix with the enzymes so that will break down into smaller units. We will absorb what we need, so it will go to our blood. In the end, we will continue absorbing water, so we will start producing feces. So what is peristalsis and segmentation? I don't have the slides with more detail about the anatomy, but basically throughout the gastrointestinal tract or the tube, we have different layers, we have different walls of muscles, okay? We have longitudinal muscles and circular muscles, and these will help when they contract and they relax to propel or to push the food. This is how the peristalsis takes place. Adjacent segments, meaning it's like neighboring segments of the intestine, will contract and relax. Okay, so they will contract, relax, contract, relax, contract, relax. Imagine all these happening in the tube. And these will move the food along the way. Okay? So it's like having these, what you do is this, right? So you are pushing the food along. And segmentation is actually single movements of the intestine that will again contract and relax. But basically here, the mixture, the food will be moving back and forth, back and forth. Okay, so all in all, you are mixing all the food. And then you have another important activity, which is digestion, right? In the end, it's not only to break it down, we have to absorb it. So large food molecules are chemically broken down into smaller units, okay? So for example, if we are eating proteins will be broken down into amino acids. Or if you eat fat, it will be broken down into fatty acids, or different types of carbohydrates will be broken down into simple sugars, right? Then we have absorption, will transport the end products from the lumen to the blood or the lymph. You remember what is the lumen? Now, this is the inside. Remember, if you have the intestine, it's not that big, of course, but if you have the intestine like this, the inside is the lumen. Okay? So what you are is transporting the end products, the nutritious substance from the lumen into the bloodstream. Okay? And the digested food must enter the mucosal cells by active or passive transport. And this is important. The small intestine is the part of the gastrointestinal tract where most of the absorption takes place. Okay, most of the absorption is going to be in the small intestine. And then finally we have defecation. What is defecation? This is the formal way of pooping, okay? Defecation. Elimination of indigestible residues in the form of feces. Feces is stool or feces, okay? Correct? Yes. Okay, so here is the food, mixes with the enzymes, absorption, small intestine, large intestine, mainly absorption of water, then concentrates and forms the feces. Okay, and in the end you defecate, so you relieve yourself, you relieve the stools. Most of the control is by reflexes through parasympathetic division of autonomic nervous system. And the chemical and mechanical receptors are in the walls of the organs. These will trigger the reflexes. Okay. Some of the stimuli that will start on the process could be the stretch of the organ. So whenever you start eating, your stomach, for example, is not the size as we see on the pictures. Okay. The stomach actually, when it's empty, will be much smaller, and because it's made up of muscle, so it can stretch. When the stomach is full, it can actually contain up to 4 liters of food. 4 liters is a lot of food, right? Then you may have noticed the more you eat, the more you start eating gradually, then it seems like your stomach starts to get bigger and bigger, right? Remember that it's a muscle, so it will stretch. So this stretch also stimulates the digestive activity. The pH of the contents, what you eat, also, and the presence of breakdown products from digestion. Some reflexes include activation and inhibition of some glands that will secrete these digestive juices or hormones. And the smooth muscle of the muscularis, which is one of the layers of the tract, that will mix and propel the foods along its way. So very quickly, we will go through these, and at the end I have a video that maybe it's a little bit more, can illustrate a little bit better. You all have the idea, right? You eat, and then somehow you have to go through all the organs that we have already seen. The food ingestion and breakdown, this starts in the mouth, right? It's mechanical, just by chewing. It will be mixed with saliva. Mrs. Suki already mentioned the importance of saliva, that it has salivary amylase that will begin the digestion. And the secretion of saliva increases when food enters the mouth, but it can also be an emotional stimuli. When you start thinking about food, it's not just a phrase to say that I'm starting to salivate just from thinking. You can actually start stimulating, okay? And there are some kind of nerves also involved in it. But the important thing is that in the mouth, there is no absorption, okay? So the food is not absorbed in the mouth. Deglutition, this is the appropriate word that means swallowing, okay, to deglute, to deglutition. So this is basically voluntary. You start chewing and then you take it in. the bolus of food. This is basically the food. As you already mentioned, it will go through your pharynx, then your epiglottis will close the connection so that it doesn't go to your respiratory system. And it will start to go down through the esophagus. And from there, we will start to have the peristalsis, pushing the food forward. Okay. So the bolus of food will start moving along the way. And remember, she already mentioned we have two sphincters here. Okay. The bolus will come, and the stomach will start to become full. We can identify different regions. This one is not the best slide maybe to talk about the regions. We have basically 5 regions. Cardia here, the fundus here, this part. In the middle, we have the body. That is easy one. Body, the pyloric antrum, the last part, and the pylorus, okay, which is the end part. At these 2 points, we have the sphincters, okay, which will close and contain the food or the will storage it in the stomach. Actually, the pyloric sphincter, this one, is the one that will control the movement of the food to go into the small intestine, okay, allowing it to cross slowly, little by little. We mentioned walls of the stomach. We have, like here, longitudinal layer. We have circular layers, and we have an additional layer, oblique layers in the stomach. Few words about the pharynx and the esophagus. The pharynx, we mentioned this time and time again, serves as a passageway for air and food. Okay, but the food is going to the esophagus. The food movement is by peristalsis. Okay, the esophagus runs from the pharynx to the stomach and will cross the diaphragm. Okay, you have here the diaphragm. Remember. Again, we conduct the food by peristalsis. And it's a passage for food only. Okay, even though they may share the pharynx, but food will go through the esophagus. In the stomach, the food is going to be broken down. The gastric juices are regulated by neural and hormonal factors. Just the sight, the smell we mentioned, and the taste of food will start to stimulate your parasympathetic nervous system. Okay, and you will start producing gastric juices. Okay, so when they bring your food, you smell, oh, this is delicious, or oh, I'm so hungry, I'm starting to think about food. Then you start preparing yourself. Your stomach will start preparing the gastric juices to receive food. We have other different glands that will produce different enzymes. Under normal conditions, a normal person can produce around 2 or 3 liters of gastric juices every day. Hydrochloric acid and enzymes to digest proteins can digest the stomach itself, and it can produce ulcers. Have you heard about ulcers? When you, for example, take too many medicines or too many irritant things like alcohol, you can have ulcers, which is like the tissues start to be corroded from the hydrochloric acid. Actually, the mucosa of the stomach, the epithelium, is in charge of producing the mucus. The mucus is alkaline. It will protect the mucus of the stomach. But the glands producing hydrochloric acid, which are needed to break down the food, sometimes may harm also the mucosa if there is not enough alkaline mucus. But why do we need these environment so harsh, this acid environment in the stomach, because it will activate some enzymes to digest, for example, proteins. Without this acid environment, these enzymes will not take their active form. Okay? And of course, it provides a hostile environment for microorganisms. Okay, they cannot survive. So it's a way also to protect ourselves. Some of the protein or enzymes that will digest protein, we have pepsine and we have renin. The only absorption that occurs in the stomach is alcohol and aspirin. Okay. So we mentioned most of the absorption is small intestine. But alcohol is not actually a nutritious substance, right? But its absorption takes place in the stomach. We mentioned the food when we put it in our mouth and we start chewing it, we refer to it as a bolus of food. Okay? Once this bolus of food mixes in the stomach with all the juices and the enzymes, and it's broken down, and it's going to go to the small intestine, we actually refer to it as chyme. Okay? This is more or less a figure of how the propulsion works in the stomach. So when the duodenum, and what is the duodenum? It's the first part of the small intestine, remember? When the duodenum is filled with chyme, remember chyme is actually the food that is processed and mixed with the enzymes, we have a reflex, enterogastric reflex, okay? Well, do you know what organs are involved in these reflex? Enterogastric. Entero from the intestine and gastric from the stomach. Okay, so this is a reflex between the intestines and the stomach. So we have the enterogastric reflex occurring, and slowly the emptying of the stomach by innervating nerve called vagus, and tightening or constricting the pyloric sphincter. In this way, we are controlling how much of this chyme is going to the small intestine. Okay. What happens in the small intestine? So here we will have already the food broken down, and we mentioned we have most of the absorption taking place here. The brush border should have been mentioned also. How do we increase the surface of these organs? If we are going to have absorption, for example, how can we increase the area of absorption? The body has very different ways to increase absorption, right? If we have an organ that is like this, we only have this surface to absorb. But if we want to increase its surface, what do? We have some projections. Remember? Projections? Okay, so the brush border is actually micro projections from the membranes. Okay, and in this way we can increase the area of absorptions. And there are some enzymes in this brush border that will break the sugars into simple sugars, or we complete the digestion of proteins. The intestinal juice itself is furin enzyme. The protective mucus is the most important intestinal gland at this point. The pancreatic enzymes will play a major digestive function. They will help to complete the digestion of starch. They will carry out half of all the digestion of proteins, and they're responsible for digestion of fat and nucleic acids. And they have an alkaline content, so the pH is higher. It will neutralize the chyme. Remember, this is coming from the stomach, okay? So it has to neutralize it. And we provide a proper environment for activation and activity of the intestinal and pancreatic enzymes. When the chyme enters the small intestine, it will stimulate the cells to produce different substances, like secretin that causes the liver to increase the release of bile, or cholecystokinin that will cause the gallbladder to contract and release bile. And these both hormones will stimulate the release of pancreatic juices. So very quickly, bile is not actually an enzyme, but it's a substance like a detergent to break down fat. Okay, you have large molecules of fat, and you want to break them down into smaller ones. That's why you need the bile. And this is also necessary to absorb some vitamins, fat vitamins like vitamin K, D, E, and A, from the intestines. Water will be absorbed along the way of all the small intestine and also the large intestine. And the end products of the digestion, most of the substances will be absorbed through active transport. So they will go through the membranes, and the lipid will be absorbed by diffusion. Again, how does the food or all these substances will move throughout all the gastrointestinal tract? Peristalsis. Okay, peristalsis is the major way how it will be moving. In the large intestine, actually the colon produces no enzymes. What we have at the end of the small intestine, when all these substances moving on to the large intestine, we have already absorbed all the nutritious substances, but we have a mass, a substance that may have a lot of bacteria. The resident bacteria that is normally located there will produce some vitamins, or are involved in producing some vitamins like K and vitamin E. And they will also, this bacteria is in charge of releasing some gases like methane and hydrogen sulfide, which are the ones that gives some of the smell of the feces or the stools or the gases that normal people can release. In the large intestine, as we mentioned, also water will be absorbed here. Okay, and whatever is left will be concentrated. So we will finish absorbing the water, and will be the material for the feces. Okay, feces or stool. The propulsion in the large intestine is actually slower, sluggish. It's long, it's slow, but it's powerful. It happens 3 to 4 times per day. We mentioned the contents are forced towards the rectum, the end part of the large intestine. And here the fiber in the diet increases the strength of the contraction, okay? And will soften the stool because it will retain more water, okay? That is why always doctors will recommend you to take more fiber in order to prevent constipation, okay? The presence of feces in the rectum will cause a reflux, so once it starts coming to full, you will have the sensation of going to the bathroom and release. But you have a couple of sphincters here, and one of them is voluntary. So you can actually stop the moment if you don't have a bathroom nearby where you can go to defecate. You can actually just contract your sphincter and wait until you find a bathroom. Okay? So defecation occurs with relaxation of the voluntary or the external anal sphincter. The next one is a short video. We will finish with this one. So please pay attention to this one. I hope it's a little more illustrating.
After viewing this animation, you will be able to describe the pathway and events that occur during digestion within the digestive system and its supporting glands. Digestion starts in the mouth, also known as the oral cavity, where mastication occurs. This is the process of chewing and mechanically breaking down the food bolus. Chemical digestion starts when the salivary glands release saliva into the oral cavity. Saliva is rich in amylase, an enzyme that breaks down carbohydrates. After the bolus has been broken down adequately, swallowing begins. The food bolus passes through the pharynx and into the esophagus. Peristalsis, which is rhythmic contractions of the muscle layers, pushes the bolus down the esophagus. The bolus passes into the stomach through the lower esophageal sphincter. This sphincter normally remains closed, preventing reflux of the stomach contents. The stomach is divided into anatomical regions: the cardia, fundus, body, and antrum. The muscular outlet of the stomach is called the pylorus. The surface of the lumen is covered in folds called rugae. Peristaltic contractions continue in the stomach, churning and mixing the food bolus with hydrochloric acid and the digestive enzyme pepsin. Neural and hormonal stimulation causes the release of pepsin by the stomach, which starts the chemical digestion of proteins. This helps reduce the bolus to a fluid-like substance called chyme. When the chyme reaches its proper softness, the pylorus opens and the chyme is slowly released into the first portion of the small intestine, called the duodenum. Peristaltic contractions continue in the duodenum. It is within the duodenum that the chyme mixes with pancreatic juice and bile. The process of digestion causes neural and hormonal stimulation of the pancreas to release pancreatic juice. Specialized pancreatic cells produce the pancreatic juice. The juice contains digestive enzymes and bicarbonate. The major digestive enzymes are amylase, which digests carbohydrates, lipase, which digests fats, and protease, which digests proteins. When pancreatic cells release the juice, it flows through tiny pancreatic ducts, which lead to the main pancreatic and accessory pancreatic ducts. Then, the juice is released into the duodenum through the major and minor papillae, where it mixes with the chyme. In order to protect the pancreas, protease is released in an inactive form and is activated once it reaches the duodenum. Bicarbonate within the juice acts to neutralize the acidic chyme, which creates a favorable environment for the digestive enzymes to function. Located above and in front of the pancreas, the liver has many roles, including the maintenance of metabolic homeostasis. The liver maintains this because it receives most of the blood flow via the portal venous system from the small and large intestines. This blood contains nutrients absorbed during digestion. The liver processes these nutrients and vitamins and helps detoxify the blood passing through the portal venous system. Another role of the liver is the production of bile, which is a liquid that contains bile salts and other substances. Bile salts emulsify fat within the small intestine. Liver cells, known as hepatocytes, secrete the constituents of bile into tiny bile canaliculi, which flows into larger hepatic ductules that eventually combine to form the right and left hepatic ducts. Bile then flows into the common hepatic duct and cystic duct, where it enters the gallbladder to be concentrated and stored. During digestion, the gallbladder contracts and pushes the bile through the cystic duct and common bile duct, where they join the pancreatic duct at the hepatopancreatic ampulla. The bile then empties into the duodenum through the major papilla. The bile mixes with the chyme and helps to digest fat. The chyme continues to mix with the digestive enzymes as it moves through the duodenum and into the jejunum, the second portion of the small intestine. Nutrients from the digested food are absorbed into the bloodstream in the jejunum. The bolus moves through the jejunum and reaches the ileum, where there is more nutrient absorption. The unabsorbed portion of the bolus passes out of the ileum and into the large intestine through the ileocecal valve. The first portion of the large intestine is called the cecum. The main function of the large intestine is to absorb water and solutes, such as fatty acids, which help concentrate and form the stool. The bolus is pushed by a peristaltic way up and through the ascending colon, which passes through the first major bend in the colon, the hepatic flexure. The bolus is now pushed through the transverse colon and then travels through the second major bend, the splenic flexure. Then the bolus moves down the descending colon and into the sigmoid colon before entering the rectum. The formed stool enters and is stored in the upper portion of the rectum. The anus contains anal sphincter muscles that remain tightly closed until neural input causes the rectum to widen. Then the stool descends, the anal sphincter relaxes, and defecation occurs.
Okay. So this is an illustration of how the process is. Is there any questions, comments? No? Okay, so we will finish it here. But I'd like to do a little more of the anatomy, maybe just a few things to give you the information on for next class, and then next class is the last one, and we will do respiratory system, a little bit of respiratory system. If you have any questions about the report, ask before submitting. Okay, if it's enough, if it's okay, make a draft, send me the draft. If you want, I can take a look and tell you if it's appropriate, or maybe you're missing half of what you should be including. Remember that you can replace with the lowest score for your quiz. So it's not a difficult way to have a better grade. And if there's nothing else, then I'll see you next week. Okay? Everything okay? Report is fine.
Okay.
Yes? Okay. Did you all receive my email last time about the classes? Because there was some misinformation last time. We only have one more class left. Okay, so next week. Then the 17th is holiday, Monday. But we don't have any classes scheduled for that day. We have by then completed the 14 sessions. So we will have 2 weeks, and then we will have the exam on the 24th. Okay, same time here. Okay, I will remind you in the next class. And for the report to replace the mini quiz, deadline will be Tuesday 18th, 9 a.m. Because there are 2 students who were not here today, I will send the information through email. Okay, so that everything is clear to all of you. Okay, thank you very much, and it's quite early. Use the time to read or study, review. Thank you.